Okay. So today we are going to start the collision and concepts related to collision. Okay.
Yes, sir.
So first of all, you are already familiar with collision. How we will define collision? So collision is defined as any process in which two or more than two particles exert some force on each other, generally a large amount of force for a short interval of time. That is called as collision. So two or more than two particles exert some force on each other for a short interval of time, that we call as collision. Now here you have to understand that for collision to take place, it is not necessary that the two particles should come in contact. Even if they are not in contact, but a force acts on the particles for a short interval of time, we say that it is a collision. Generally during the collision a large amount of force acts. Now here you have to understand that whenever some force will act on particles, force always changes momentum of the particles, because force is rate of change of momentum. So when force acts on the particle, then momentum of individual particles will change. For example, here you can see that when you pulled this bob slightly and then left it, what will happen? It will start moving, it will go, and then it will hit this another bob. And when it will hit the another bob, then a large amount of force, or you can say some finite amount of force, will act for a short interval of time, because after that they will separate again. Now here you can see that whenever collision will take place, for simplicity, let's limit to only two particles. So when collision will take place between two particles, each particle will experience a force because of Newton's third law, right? One particle will exert force on another. First on second, second will also exert same force on first in opposite direction. So if we look at the net external force on the system of two bodies colliding with each other, there is no net external force, because particle 1 is exerting force on particle 2 and particle 2 is exerting same amount of force in opposite direction on particle 1. So the resultant of these two forces will be always 0. And anyway, these two forces are internal forces. So there is no net external force on the system. Suppose these two particles combined is my system. So particle 1 exerting force on second and second exerting force on first. These are internal forces. Internal forces cannot change the momentum of the system. Internal forces can change momentum of individual particles, but it cannot change the momentum of the system. So because in most of the collision, generally, there is no external force, so momentum is conserved. Or you can say that whenever there will be no external force during a collision, then the momentum of the system will remain conserved according to law of conservation of momentum. Because momentum changes only when there is some external force acting on the system. What is the meaning of momentum of the system? Momentum of the system means vector addition of momentum of all the particles of the system. So here in this system, there are only two particles. This is first, this second particle. So initial momentum of these two particles will be equal to final momentum of these two particles. What is the meaning of initial and final? Initial means before collision. Final means after collision. So here you can see.
Any point, sir. And after
Sorry.
collision at any point.
Sorry.
Sir, before collision means just before collision or at any point before collision. Here we need to consider.
Just before collision.
And just
If,
after collision, sir.
if suppose if suppose before collision and after collision also there is no external force, then you can take at any time before collision and any time after collision. But suppose that just before collision there is some external force, after collision also some external force is there. We will come to it a little later, but the force is not impulsive. For example, gravitational force is not an impulsive force. So if two particles collide in air, before colliding also gravitational force is acting. After colliding also gravitational force is acting. But the gravitational force is not impulsive. But it is an external force. So here we will have to take just before collision and just after collision. So always it will be better if you say just before collision, just after collision. Always. Just before collision, just after collision, momentum will be conserved if there is no external impulsive force acting on the system. Okay, now here you can see that the total momentum before collision will be equal to total momentum after collision. Now there is a term called as coefficient of restitution. So collisions are of different type. One is elastic, perfectly elastic collision. Another is perfectly inelastic collision. And the third category is partially elastic collision. So that third category, partially elastic, is not perfectly elastic and not perfectly inelastic. It is somewhere in between. Now, coefficient of restitution is defined for all type of collision. So let's try to understand how it is defined first. So it is simply defined as the ratio of relative velocity of two colliding particles after the collision to the relative velocity before the collision.
Collision, if
Here you have to understand that suppose if these are the two particles, so this is the first particle and this is the second particle, and this is the situation before the collision. After the collision, again this is my first particle and this is my second particle. Now here you can see that before the collision this particle was moving, and suppose this particle was at rest. After the collision also this particle's velocity will decrease slightly. But what will happen to this particle? It was initially at rest, but now it will be moving with some velocity. Now you tell me that before the collision, separation between these two particles were increasing or decreasing?
decreases,
And what will happen after the collision?
increases.
Separation between these two particles will increase. Okay. So when we say relative velocity, actually it is relative velocity of approach before collision, and it is relative velocity of separation after the collision. So ratio of that. So relative velocity of separation after the collision divided by relative velocity of approach before the collision, that gives you the coefficient of restitution. So you can see V2 minus V1, but look at the denominator. It is U1 minus U2 because U1 is bigger now. U2 is 0, is at rest. But after the collision, V1 will decrease and V2 will increase. So bigger minus a smaller. Are you getting?
Yes, I'm getting.
Okay. So that ratio will give you a number. It is a unitless number. That number just gives you an idea about the type of collision. Now we will discuss about coefficient of restitution in every type of collision. So let's first start with the first type of collision, which is elastic, or it is also called as perfectly elastic collision. Whenever they write simply elastic collision, it by default it means perfectly elastic. Now, the type of, so what is perfectly elastic collision? Perfectly elastic collision is a type of collision in which total kinetic energy of the system before the collision is equal to after the collision. Here, this word is not correct. So this is the type of collision in which kinetic energy of the system before and after the collision is same. Is same. Are you getting?
Sir, I'm getting. Sir, in the collision, uh, sir, if you said the momentum is conserved before and after collision, sir, can we
Yes.
take the momentum at the distance L before collision and the distance L after collision? Their momentum also will be equal, sir. We can.
No. Means it will be if there is no external force before and after the collision. Are you getting?
Yes, sir.
But if there is external force, it will not be. So just before collision, just after collision.
If external force also there, then before and after it will be equal.
Always. Before, just after, always it will. But
Yes, sir.
here you have to understand that the condition is that there is no external force acting on the system during the collision. Are you getting? No external impulsive force on the system during the collision. If this assumption is true, then just before and just after collision conserve.
But if external force not acting and at any distance equal from the collision, the momentum will be conserved. Sir.
Not getting. Again,
Sir, if
can you
we
repeat?
consider the system, the two bodies. Sir, if we consider the two
Hmm.
bodies at a distance of L from collision, sir, each side before and after, if there
Hmm.
is no external rooms,
So if
external
there is
force
no
acting on that,
external force, if there is no external force, then always conserve, not at a distance L and L, equal distance. At distance L1 and L2 also same. Are you getting?
yes, sir, I'm getting.
So it has nothing to do with distance. If there is no external force, always conserved. Means at any
Yes, sir.
distance. Hmm.
Yes, sir, I'm getting.
Hmm. Okay. So what is elastic collision? It is a type of collision in which initial kinetic energy of the system remains becomes equal to final kinetic energy of the system. Can we say that kinetic energy of the system remains constant in elastic collision?
Yes, sir, we can say for
No, that is wrong. That is a
initial and final. Oh, understood. Only initial and final will be same.
only initial and final will be same. Many books write this, that kinetic energy is conserved, and that is wrong. In SC Verma, there is a MCQ question. So when you solve SC Verma, you must solve objective 1 and objective 2 questions. Are you
Yes,
getting?
sir, both hands only, sir.
In
Understood.
every chapter, objective 1 is single correct and objective 2 is multiple correct. And they are very good questions. Concept, it will clear your all the basic fundamental concepts. Excellent questions. And mostly objective 2 is much good level. So both you should solve. So there this question is asked that in multiple MCQ, multiple correct question, that kinetic energy of the system remains conserved, and one option is saying that initial kinetic energy is equal to final kinetic energy. So only this statement is correct. Initial is equal to final. Okay, then it is elastic collision.
What is
What about
conservation?
momentum? Momentum always conserved. So momentum always conserved means it is not just before and just after, it is also during the collision. Are you getting?
Yes, sir, I'm getting.
It is in case of the difference is that kinetic energy during the collision is not conserved, but momentum is conserved. It is not initial and final are equal. Momentum is conserved. Conserved means from just before to just after, in this interval, every instant momentum of the system is same. Are you getting? Just before
Sure.
whatever is the momentum, from that instant to just after the collision instant, at every instant, momentum of the system is same, every instant. But that is true for momentum of the system, not the momentum of individual particle. The same is not true for kinetic energy of the system. Kinetic energy just before is equal to just after, but in between, during the collision, it is not.
Then what is it?
So here you can see everywhere they are using momentum conservation. Momentum conservation takes place in all type of collision because it has nothing to do with the type of collision. It has to do with whether there is external force acting on the system or not. Conservation of momentum. So momentum of the system remains conserved if there is no external force, or you can say impulsive external force acting on the system. Yeah, tell me. Now you can ask.
What is the general meaning of conservation? I mean, it is
Conservation, general meaning of conservation is it has same value at all the instant.
we get the constant value, sir. Every time it is constant.
Constant value not fluctuating. Yes.
Yes, sir.
Not initial equal to final and in between changing. Then it is not conserved. Conserved means at every instant, means constant function of time. It has no, it do not vary with time. Okay, so here you can see it is clearly written kinetic energy system before collision is equal to kinetic energy of system after collision. Nowhere you will see that they write kinetic energy is conserved. Okay, that's it. Now, one more feature that you will understand, that coefficient of restitution for a elastic collision comes out to be 1. That you can also derive by writing the equation of conservation of momentum and by writing the equation initial kinetic energy equal to final kinetic energy. When you will simplify and find the coefficient of restitution, you will see that it is coming out to be 1. So coefficient of restitution will be 1 for a perfectly elastic collision. What does it mean? It means that the relative velocity after collision, relative velocity of separation after collision will be exactly equal to relative velocity of approach before collision. Here you have to understand that coefficient of restitution has nothing to do with mass of the colliding body. Are you getting?
Yes, sir, I'm getting, sir. Without mass.
Okay. So you can, whenever the question is saying that it is perfectly elastic collision, you can also use E is equal to 1. Or if the question is saying that E is equal to 1, then you can understand that, okay, it is a perfectly elastic collision they are talking. Now we will go to another extreme and we will talk about the I think they are not talking about perfectly inelastic. Now they are talking about inelastic collision. When we say inelastic collision, inelastic means that it is not perfectly elastic. And when we say perfectly inelastic, that is a different third case. So now we are talking about inelastic collision. Inelastic means that kinetic energy in just before and just after is not equal. Then we say the collision is inelastic. So if the kinetic energy just before and just after is not equal, it means that there is some loss of kinetic energy. What happened to that kinetic energy? Where is the kinetic energy? That kinetic energy is lost from the system in form of heat or sound or anything, internal energy or whatever. That energy now cannot be recovered.
So means in deformation also it can be used for the energy.
No, means what happens in inelastic collision, that when two bodies collide, there is some deformation during the collision. There is some deformation, so some part of the kinetic energy goes into the elastic potential energy. Some part, not all the, and some part is lost. So some part is recovered back and some part is not recovered back in inelastic collision. Whereas in perfectly elastic collision, perfectly elastic, what happens, that kinetic energy of the body gets converted into the elastic potential energy. Some part of that gets converted into elastic potential energy of the system, and it is 100% recovered back from elastic to again kinetic in perfectly elastic. Whereas in perfectly inelastic, it is not recovered back 100%. Some amount is always lost.
So what is the general meaning of deformation? So means
Deformation
dispersion.
is deformation, you are asking. So deformation simply means the change in shape and size of the body. For example,
Yes.
if there is a balloon and you compress it, so you change its volume and you change its shape, that is called as deformation of balloon. Are you getting? And the force that you are applying on the balloon to change its shape and size, that force is called as deforming force. Are you getting? Now in this type of collision, you will get coefficient of restitution value from 0 to 1, any value between 0 to 1. So 1 is for perfectly elastic and it is inelastic collision. So it will be somewhat lesser than 1. It will be in between 0 to 1. But momentum will be conserved in all type of collision. Momentum of the system will be conserved in all type of collision. So one equation you will get in all question, which will come from momentum conservation. Are you getting? Second equation you will get in all the question, which will come from coefficient of restitution. If suppose coefficient of restitution value is given in the question. If it is not given, then you cannot use that coefficient of restitution equation. Are you getting?
I think getting.
But they will definitely give you some information. They can give you that, okay, 30% of kinetic energy is lost in the collision. So then this information they have given you, loss of kinetic, some information additional they will definitely give you apart from conservation of momentum, so that you will get two equation, and then depending on how many unknowns are there, how many equations are required, many question will be there which you can directly solve simply by applying conservation of momentum. Now here you have to understand that when I say initial momentum will be equal to final momentum, momentum is a vector quantity. Now whenever in case of any vector quantity we say this is equal to this, you have to understand that you can break it into three components. One component along x-axis, one component along y-axis, and one component along z-axis. And you can conserve momentum separately along x-axis, separately along y-axis, and separately along z-axis also. Just give me 2 minutes. I will be back in 2 minutes. Okay. Till then, you just go through this slide. I will be back in 2 minutes.